Hey, everybody, and welcome to the first short lecture from Chapter 5 in your textbook. And today we're going to talk about organizations as communication systems. And in particular, we're going to talk about looking at organizations in terms of a school of thought that's known as systems theory, right? So we've talked about organizations in terms of scientific management, in terms of bureaucracy and bureaucratic control, and in terms of the human relations school of thinking. And so systems theory has some things in common with that human relations aspect, but it's really kind of a broader approach in a way. So again, I want to talk about this systems perspective and how this works, how we think of things, and how it arose as sort of a way of looking at organizations in relation to historical context. So for 200 years, right, the main thinkers in terms of understanding the world, right, tried to understand it from what we would call a deterministic reductionist perspective. So this is obviously fancy academic language, but the idea is that we're trying to reduce both the natural and the social world to its kind of essential components, right? We're taking a scientific, very rational kind of approach, like we see with scientific management, right? That would be a good example of how people tried to take a deterministic and reductionist perspective to social organizations. And so this view oftentimes tried to look at the world and the people who live in it as machines, right? And they thought that they could explain our world in a causal, linear kind of way, right? One thing happens, and then as a result, something else happens, right? And so the hope was, of course, that the scientific method, the method that undergirds all scientific and medical thinking, right, could be used to reduce reality to its basic indivisible elements, right? The smallest parts. And when you think about it, this is what science does, right? In physics, we talk about atoms, right? In biology, we talk about cells. We're always trying to break things down to kind of their smallest components and then build from there, understand how things build from these small components. Now, one of the criticisms of this approach is that it examines phenomena in isolation, right? So if you're examining something, think about it, if you're examining something in a lab, for example, you're thinking about it in isolation. You're thinking about it in the context of one very specific environment. And in fact, you're taught to control for the surrounding environment, right? You're taught to control the possible things that can affect your research and your ability to scientifically examine something. And of course, Taylor's scientific management, the Taylorization of labor, it worked this way, right? It was very much based in these kinds of ways of thinking. Sorry about that. So then this brings up a question, right? Are there problems with this way of thinking? And I guess, since you're not here to answer the questions, I'll answer the question myself. But what I suggest to you is that this kind of very rational, scientific, reductionist way of thinking breaks things down that might not be best examined from this perspective. People, as we know, aren't things, right? People are people. And so as a result, their behaviors are tough to scientifically analyze in many ways because their behavior just simply isn't rational, right? Human beings don't work they don't think in linear ways, right? They don't behave in linear ways. Cause and effect have limited authority in the world of irrational people, right? If we were all rational, none of us would smoke, none of us would drink. All we would do is stuff that's good for us, right? We'd always presumably make the right choices, right? And we know it's just not that way. So obviously, this way of thinking ignores a lot of what we might call the human elements of organization and culture. So systems theory arose as sort of a challenge to this dominant way of thinking, right? Now, it's important to realize the scientific method, this belief in rationality, brought us a lot, right? I mean, it gave us the Industrial Revolution, it changed our lives, it changed the way we live, it's offered us all kinds of really important new technologies that arguably have really changed our lives for the better. But again, uh, during the last century, during the 21st century, um, we really see challenges arising to this way of thinking, and we even see them in science, right? So, for example, Einstein's theory of relativity showed pretty conclusively that space and time are inseparable. Now, prior to this, right, prior to Einstein and his theory of relativity, we thought of these things, space and time, as distinct, as discrete entities, as separate things, right? Because you remember, in science, we're always trying to be reductionist. We're always trying to reduce things down to their key elements. But Einstein comes along and he says, hey, guess what? Space and time are related, and indeed, your experience of space and time is relative, right? It depends on where you are and how fast you're moving, right? So, time and space rather, are experienced differently depending on your perspective, and that makes it relative. It's not a constant. It's not an objective constant, in the same way that it was presented previously, right? Heisenberg's uncertainty principle works in much the same way. Quantum theory has shown us a lot about how particles operate in ways that aren't uh, really consistent with the kind of causal logic that we've come to sort of appreciate as the main force that undergirds science. And so what we see then is that the determinism and the reductionism of the mechanical age eventually sort of became the indeterminacy and perspectivism of the systems age, right? So that means that we begin to look at things from varying perspectives, and we begin to understand how things are interrelated, right? If traditional science is always trying to break things down into its individual parts, system theory looks at the way all these parts interact with each other. And in the case of systems theory, you work in probabilities rather than certainties. And this is, I mean, although maybe maybe this doesn't strike you as a really important distinction, I suggest to you that it is, right? That we understand that things are probable rather than certain. That means a lot in the grand scheme of things. So this is a short video for kids about Einstein's theory of relativity. If you're interested in a more thoroughgoing explanation than what I was able to provide concerning the relativity of one's experience of space and time, this would be a great place to learn it. But I'm not gonna play it here for the sake of keeping things short. But if you want to check it out, I encourage you to do so. And so one of the thinkers who really influenced this systems theory broadly is Bertalanffy, right, which is a tough name to say, but a thinker who theorized the world as a great organization, right? And so he comes up with this quote: "We come then to a conception which, in contrast to reductionism, right? So to unpack that, in contrast to reductionism, so in contrast to the way we were doing things before, we may call it perspectivism. We cannot reduce the biological, behavioral, and social levels to the lowest level, that of the constructs of laws and physics." So he's saying, look, science doesn't work when you're talking about human behavior and society, right? So the mechanistic worldview is taking the play of physical particles as ultimate reality, found its expression in a civilization which glorifies physical technology and that has led eventually to catastrophes of our time, right? The catastrophes of our time. So what he's talking about there are some of the great tragedies of the last century, right? He's talking about things like the Holocaust in Germany, for example, right? So he says possibly the motto of the world is a great organization, so as a system, right, rather than trying to reduce the world to its basest parts and deal with it in terms of causal reason, can help us reinforce the sense of reverence for the living, which we have lost in the last sanguinary decades of human history. And so, part of what Bertalanffy's talking about here, again, are things like the Holocaust. So you have the Germans during World War II who kill 11 million people. Now, what he's suggesting, at least in part, and this is sort of in keeping with the same philosophy that we saw coming from the Frankfurt School thinkers, right? The German Jewish intellectuals who fled Germany during World War II and made their home in California. You know, they argue that the Enlightenment, that this move towards reason and science has done a lot for us, but at the same time, it's what has allowed us to commit atrocities, right? To do really terrible things to one another. And of course, the Germans were very rational folks in one regard, right? And they utilized this the taylorization of labor and the assembly line style of production that Henry Ford came up with in order to commit horrible atrocities and kill people en masse, right? To kill 11 million people in a factory kind of setting, right? I mean, you can even tell here, and I'm sorry, I know this is a terrible image, but I think it really conveys what I'm trying to get across. When you see bodies just sort of stacked like cordwood, you understand that what's happening here is clearly related to reductionism and reducing people to things, right, in a sense. And it was this kind of impersonal scientific view that allowed this to happen, right? I mean, it gave them the tools to make it happen, and it gave them the mindset to make it happen, right? And the same can be said about the atomic bomb, right? The dropping of the atomic bomb on Hiroshima that killed well over 100,000 people, right? I mean, men, women, children. Science enabled us to do this, right? But it's one of those situations, what is it, like Jeff Goldblum in Jurassic Park, right? Like you were so eager to see if you could do it, you didn't stop to think about if you should, right? And clearly we were in a race to develop this kind of technology. We were worried about what happened if other countries gained this technology before we did, and we used it to effectively end the Second World War. And of course, the argument is that if we didn't, then many more people would have died in the continued fighting. So, I mean, it is a complicated and knotty kind of moral or ethical question that you're dealing with here. But nevertheless, let's not stop let's stop for a moment and think about the fact that, it's the same scientific method. It's the same embrace of rationalism and reductionist kind of scientific thinking that gave us air conditioning and iPhones that resulted in these kinds of tragedies, right? And so what he is saying, Bertalanffy, is that, let's look at the world in terms of systems theory as a great big system, because that allows for a human element that hopefully avoids these kinds of tragedies, right? Because we're not reducing people to things, in a sense. And so what he's referring to, again, is the fact that, in systems theory, things are considered interrelated, right? Everything is interdependent. This is something that we're beginning to realize, right? I mean, it's something that we're grappling with. So, for example, with climate change and global warming, that's something that the people of the Industrial Revolution never would have even considered, right? The idea that we were powerful enough to create an industrial system that would threaten the very planet that we live on, right? I mean, this was sort of beyond the scope of their thinking because, in fact, they didn't see these things as a system, as being interrelated, right? So one of the central principles of systems theory is that all things are interdependent, that all things are interrelated. And of course, with this kind of thinking, there's a strong moralistic kind of tone, right? Practitioners of systems theory view themselves as morally and scientifically superior to the other folks, right? Indeed, they think that the mechanistic worldview, looking at people in the world and trying to understand them as if they were things or machines, and trying to understand the world this way undermines our morality. that you wouldn't have an event like the Holocaust if we thought about the world in terms of systems and interdependence. Uh, it's only enabled when you think about people as things and people in terms of isolation and not being interrelated and interdependent, right? So again, in this sense, it's similar in tone and content to the thinking of the Frankfurt School theorists, the folks that tried to look at Marxism and bring it up to date for a new century. All right, so that's it. Sorry, that first lecture was kind of a bummer, but the good news is it gets more optimistic from there. So next time we'll talk about principles of the system perspective. So thanks for checking out this video.